In this video, let's talk on Pythagoras rule or Pythagoras theorem. Now the first thing we will talk about is the right angled triangle. Now this is how a right angled triangle look like. So this is a right angle triangle. Why is it called right angle? Because the angle here is 90 degree. So this 90 degree is what we call right angle. Now in any right angle triangle, the longest side is the hypotenuse. That is from here like this is the hypotenuse to this place. So that's the longest side. So we call it hypotenuse. So why the angle theta? So where the angle theta is facing is called the opposites. Yeah. Why where they both sit is the adjacent. So how can you identify hypotenuse? The hypotenuse is where the angle 90 is facing. So where that 90 is facing is hypotenuse. So look at it. This is the angle 90. See where it's facing? Straight down. So that is hypotenuse. So where this one is facing like this is opposite. And where they both sit is adjacent. Now the first thing you need to identify in any right angle is hypotenuse, opposite and adjacent. Now the adjacent can also be the base. As we can see, you have already know that anywhere this 90 is facing is the hypotenuse. Anywhere this theta is facing is the opposite, and where they both sit is the adjacent. So let's see different diagrams that you can locate the hypotenuse, opposite and adjacent. Now let me say the diagram is facing this way. If the diagram is facing this way, so where is your opposite? Where is your hypotenuse? And where is your adjacent? If I label the three sides A, B, C. So let me call this place theta. So now look at this diagram. Where is opposite? Where is hypotenuse? And where is adjacent? The first thing is that you need to locate this angle 90. This place is angle 90. Anywhere this angle 90 is facing is the hypotenuse. Anywhere this theta is facing is opposite. And where they both sit here is the adjacent. Like that. Now let's say the diagram is like this. Now where is your opposite? Where is hypotenuse? And where is adjacent? Now the hypotenuse, locate where this one is facing, that is the 90. Where the 90 is facing is the hypotenuse. That means this place is the hypotenuse. Where this one is facing is opposite. And where they both sit is adjacent. So no matter how we draw the triangle, you can locate the opposite, hypotenuse and the adjacent. Now let's see more diagrams. So now let's say the diagram is like this. let's say the diagram is like this. So now, where is your opposite, where is hypotenuse, and where is adjacent? Now you will see this 90. Where this 90 is facing is the hypotenuse. Anywhere this 90 is facing is the hypotenuse. Anywhere this other one is facing is opposite. And where they both sit is adjacent. Now the diagram can be anyhow, but no matter how we draw the diagram, your target is where is the opposite, where is the hypotenuse, and where is the adjacent. Now let's say the diagram is like this. Now where is your opposite, where is hypotenuse, and where is adjacent? It's obvious the opposite here is where this 90 is facing. So the hypotenuse is where this 90 is facing. That means this place is the hypotenuse. That's the longest side. Where this other one is facing, the theta, is opposite. And where they both sit here is the adjacent. Now then I'll draw a triangle and ask for the number in each triangle. So now let's say we have this. Five, 4, 3. Now in this right angle triangle, what number can you see in the hypotenuse here? And what number can you see in the opposite? And what number can you see in the adjacent? Now the hypotenuse is where the 90 is facing. That means here we short hypotenuse. We write H Y P. So which is equals to 5. You short it as hypotenuse. Now where this one is facing is opposite. So that means OPP, you short it, that is opposite. The number there is 3. And where they both sit is adjacent. You short that one too, that is adjacent, is equals to 4. So let's see another diagram. Let's say we have diagram like this. Now let me call this place 13, 5, 12. Now what number can you see in hypotenuse here? And what number can you see in opposite? What number can you see in adjacent? Anywhere this 90 is facing is hypotenuse. So that means my hypotenuse is equals to 13. Anywhere this one is facing, the angle theta is opposite. So I can say OPP, that is 5. And anywhere they sit is adjacent. So that is adjacent is equals to 12. So now let's say Pythagoras Theorem. Pythagoras Theorem states that the hypotenuse square is equal to the opposite square plus adjacent square. Now let's call this our right angle. Y here is angle theta. Now let us assign box here. So I'll call this box 3 units. 1, 2, 1, 2. Again, let's have another box there. This one, let's make it 4 units. Let's make this 4 units. 1, 2, 3. 1, 2, 3. If I say 3 units, it means 1, 2, 3. 3 boxes. 4 units means 1, 2, 3, 4. So 4 boxes. Then let's make this one 5 units. This place, let's make it 5 units. 1, 2, 1, 2, 3, 4. Try and balance. 2, 3, 4. So here also 1, 2, 3, 4. So this will be 1, 2, 3, 4, 5. So like that. Now, if you count the total number of boxes here is 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of boxes is 9, which is the same thing as 3 square, because 3 square is 3 times 3, that is 9. What is the total number of boxes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Total number of balls here is 16. So which is the same thing as 4 square, because 4 times 4 is 16. Now what is the total number of balls here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And 25 is the same thing as 5 square, because 5 times 5 is 25. Now, Pythagoras theorem states that the hypotenuse square will short hypotenuse as HYP is equals to opposite square plus adjacent square. So that is Pythagoras theorem. So if I ask you, tell me Pythagoras theorem, you will say hypotenuse square equals opposite square plus adjacent square. Now what is the number in the hypotenuse? Where is your hypotenuse? Here, I've told you where this 90 is facing is the hypotenuse. That means in this case our hypotenuse is 25. That will be 5 square is equals to let me use 25 first. That means 25 is equals to, that is hypotenuse square, is equals to, where is opposite? Opposite is where this one is facing, so the number of the opposite is 16, plus now where the two sits is the adjacent, and the adjacent is 9. If you look at this, 16 plus 9 will give you 25. So Pythagoras theorem now says the hypotenuse square, because 25 can be 5 square, is equals to opposite square, 16 can be 4 square, then plus adjacent square, adjacent can be 3 square. That means I have assigned a number here now, that hypotenuse is 5, opposite is 4, and adjacent is 3. The Pythagoras theorem now states that hypotenuse square is equals to opposite square, that is 4 square, plus adjacent square. So that is Pythagoras theorem. Now let's see how we can use Pythagoras theorem to find any missing sides in a right angle triangle. Now let's say we have something like this. So if here is theta, let's say here is 3, here is 4, then if here is x, now what is the value of x? So find x. Now to find x, here locate all the sides. Now what are the sides you know in this diagram? Now I can see anywhere this one is facing is hypotenuse. That means my hypotenuse is x. So anywhere this one is facing is hypotenuse. So hypotenuse is x. Anywhere this one is facing is opposite. So that means opposite is 4. And where they both sit is adjacent. So adjacent is 3. So now using Pythagoras theorem, Pythagoras theorem states that hypotenuse square is equal to opposite square plus adjacent square. So put all the numbers. So hypotenuse is x, so that will be x square is equals to opposite square, that is 4 square, plus adjacent 3, so adjacent is 3 square. You have all the values here, so you list it out. So that means s square is equals to, now what is 4 square? 4 square is 4 times 4, so 4 times 4 is 16, plus 3 square is 3 times 3, 3 times 3 is 9. So s square is equals to 25. So 16 plus 9 is 25. So to remove this square, so you find the square root of 25. So if you check your 4-figure table, you will see square root of 25. Check your 4-figure table. It's at the back of your textbook or your 4-figure table. So square root of 25 is 5. So that is the answer. Now let's see another question. The diagram can face anywhere. So now let's say the diagram is like this. Now here is 90, here is theta. So let's call this place 5, let's call this place 13, then find this place y. The alphabet can change. Now before you solve, first locate where is your hypotenuse. Which two sides do you know? You know hypotenuse. Anywhere this 90 is facing is hypotenuse. That means your hypotenuse is 13. Anywhere this one is facing is opposite. You know your opposite as 5. And where they both sit is adjacent. So you know your adjacent as y. So hypotenuse, where this one is facing, opposite and adjacent. Now use Pythagoras theorem. So that will be hypotenuse square is equals to opposite square plus adjacent square. Now what is hypotenuse here? Our hypotenuse is 13. So that will be 13 square is equals to, what is your opposite? Opposite is 5. So 5 square plus what is adjacent? Where they sit, so adjacent is y, that is y square. Now can you say 5 square plus y square? No. So 13 square is what? 13 times 13, that is 169. 5 square means 5 times 5, that is 25, plus y square. So can you say 25 plus y square? No. So if you cannot add it together, then take this one to the other side. So if you are taking it to the other side, this will be 169 minus 25 is equals to y square. So you carry this one to the other side. So 169 minus 25, that is 144, is equals to y square. So to remove this square, you are going to say square root of 144 is equals to y. So if you check your 4-figure table, square root of 144 will give you 12 is equals to y, or y is equals to 12. That means to use Pythagoras theorem, first you will need to know the size that you know. Then you will list it out like this and use the Pythagoras theorem. So you can try the rest. So in your 4-figure table, you can check square root of any number there. So I'll give you the one you will try. Thank you.